is that I'll have, we'll do the second set of, we'll start the cycle for the second set of, presentations next week, and it'll be some things involving ancient Greece. And then I'll have a video for you. We'll still be talking about ancient Babylonia a little bit on Tuesday, but I should have a video for you either for Tuesday or for Thursday about sort of the introduction to Grecian mathematics. And it depends on how far we get after today. I'll have a better sense of that. Okay, so sorry, Colin, if you're there, looks like there's an issue with you joining. Hopefully you'll get here. Let's see if you're in yet. No, I'll wait just a second, see if you can join. So I have a question. I'm just kind of curious. How are the connections been at Drake? Have you been able to stay on with your courses when you're meeting remotely?
For the most part, yeah.
Yeah. I noticed a couple of people today in other classes got kicked off, and I think they were on campus. And I don't know if that's something that's common. Are people being able to stay on pretty stably in most classes?
I think some people were having internet problems at GK.
Yeah, I don't know where it was at the students, where I had the students, where they were. Okay, I just was curious. So anyway, this is all kind of messed up. It got dog-eared, but what I wanted to do, and I'll just break you up into groups in a minute or so, is start with 7. And if you wanted to look over anything else from that sheet, when we come back, you can bring questions about it. And then I'm also going to start with the 6th handout today, and that's more complicated in terms of how you use it. It takes some getting used to, but we'll get to there when we get to it. So I'm gonna, unless if there's any questions about anything, I was just going to form 4 groups. Okay, and start with number 7 from the handout, and then if you want to go over other things on there, we can talk about that when we come back. Okay, so here we go. So everybody's in a room. Oh, am I in a room? I think I am in a room. I don't need to be here. No, everybody's in a room. Okay, good. Okay, good. Yeah, so I'm all alone for a sec. So you're gonna cook?
Yes.
Okay, good. I probably need to eat by, they say 10 hours, so 10 o'clock, but it shouldn't be a problem, right?
No.
Yeah.
I don't like eating quite that late anyway.
Yeah.
So yeah.
I didn't think so.
I will, I think I'm gonna go on a little walk, unless you want me to wait till you're done with class to walk with you.
No, I'll have a few things to like, I wouldn't mind just doing a few organizational things.
Yeah, I think I'm gonna go on a walk, and then I might, after I get back, if there's time, run in, and I have a long thing to scan that I think I can do at the office just quickly.
Yeah.
It'd be a lot faster, and then come back and cook.
Okay, sounds good. I'm trying to think if I'm going to send you to my office because I have a book there, but I don't know if it's there yet, so I'm not going to. Okay. Hey, just checking in, and if there were any questions, and was I right that you were pretty much 7 was all that was left? Or do you have other questions too?
think just number 7.
And any questions about anything?
I'm just a little confused about the whole multiplication thing still.
So let's
Doesn't
look.
seem very natural.
Okay. I'm going to try something, see if I can get my camera in here. I don't think I can. No, I'm only one. It's funny. Here, let me try something. See if I can do this. What room are you? Your room
4.
4. Okay, good. Let me see if I can join twice. I think I tried this once before and it didn't work. Okay, I can't do that. I think I know what I can do, but not today. Yeah, so I don't have the camera, so I'll just use the whiteboard, Eric, and I'm going to start with a smaller number. And I wouldn't worry too much about the decimal points. I'd get rid of them and then put them back. Okay. And then, okay, so let's say I'm just going to do like, let me see, I'm making up a number here. Maybe I'll do, okay, we have this number up here. I'll start with something that's close. Okay, so we have 23, 0. Again, I'm not going to worry about the decimal. And I'll just put it back when I'm done. Times 8, okay, just to get it started. Okay. I have to clean up my screen just because some of these floating. Okay, there we go, good. So remember that, okay, so here's what I do. I'm gonna do, especially when the numbers get, let me make this 18, just so we're really gonna go over everything, okay? Okay, so what I have to do, 18 base 60, I have to actually start with, I'm gonna do the base 10 work over here, so that's 160. And then 10 times 20 is 200. And so I get 30. This works out too well. Okay, that's all right. Now that's base 10, so now I need to convert that to base 60. And what do I do for that?
6, well, you can divide by 60, right?
Yeah, get 6, right?
Yeah.
Exactly, so that's gonna be 6 60s, which you'd write like that. Just like this means 2 10s, and this means 1 10 and an 8. This means 6 60s and nothing else. So I would put my 0 here, and notice when I did, no, I didn't have to do that over here. But then I have the 6 that I'm going to carry, right?
That's 18 times 0, which is nothing, but yeah, you still have the 6.
Right. And so there's 18 times 0, so I'm going to carry that 6 down. Okay. And now I do the same thing. I'd have to do 18 times 23 on my own. You can use a calculator any way you want to do it. So if you want to give me an answer for that.
414.
414?
Yeah.
Yeah. Oh, yeah. Okay, so 414. So then I got to figure out, like the algorithm that I use is I go 60, how many times does 60 go into 414? And then I'm going to look at my remainder and then that should be it. So I think 6. And then I have a 54 remainder, and that's less than 60. So when I convert this to base 60, it's 6 comma 60. I'm sorry, 6 comma 54. Okay. So that means this 54 then would go right here. And then my 6.
Drop the next 6 in
Yeah.
there.
Yeah.
Okay.
And that's, you know, if you think about it, what we did here, 8 times 0 is 0, 8 times 20, 8 times 2 is 1 6. So I put put the 6 down. 8 times 2 is 1, and then I kind of carried that one.
Yeah. I think what I was getting most tripped up on was the semicolon. And
Right.
if I line those up or just,
Now
like
we're
you say, just drop it.
Now we're gonna do it, okay? I'm gonna throw it in there. Okay, so like, let me do something base 10, okay? With a calculator, you don't need to do this, but it's kind of like the old-fashioned way of doing it. So let's say I got 5.1 times 22, 2.2. Now I can do it this way, 51. I can ignore the decimals, but then what do I have to divide my answer by?
Probably 100. I don't know.
Yeah, by 100. So I think, what's this going to be? It's going to be 5, 10. I'm sorry, it's going to be, I can't do this in my head. It's going to be that plus this. So it's going to be 1122, I think. Thank you. Okay. So then now I just put the decimals back in. And this is where I started without the decimals, but I have 2 to do. So I put it right here. So let's say that this problem over here is a little bit different. And then I have a semicolon here. And then I have one here. So how many, what do I have to do to change my answer?
Put it 3 places in from the right.
Yep.
Okay.
Again, you haven't thought why you do that with base 10 and a long time. So it's like when you have to apply it for something else, almost everybody goes through this. Like I remember when I got this problem, I had to it took me a while to get my head on straight about it.
This was helpful. That makes a lot of sense.
Yep. Okay, good. Other questions? Okay. Do you want me to leave this up or erase it?
Good to erase, I think.
Okay, well, I'll just stop the share. And I think you all can share, so you're good. Okay. Okay, anything else? No? Okay, good. Okay, see you in a bit. Just checking in to see how you all are doing.
We're trying different methods. We're trying to we're trying one where we just try to do the multiplication as we would normally, base 60, and another where we just convert it in and convert it back.
Yeah. To
Both
check.
have failed.
Oh.
We're gonna try again.
So, by the way, my answer here is, I realized this at the end of class, so I put it out in an email, but it might not have got through to everybody, but it's not 7/13/24, it's 7/11/24.
11/24.
Yeah. And then okay, good. And it's the sheet that's up there now is all it's up to date. Okay. So you're just going to work it out, or you have any questions?
We're just trying again, see if that works out.
Okay. Okay, anybody else?
I think we're good.
Okay, good. Okay. Let's see. I'm trying a new technique to move. Okay, good. Okay, see you in a bit.
Yep, see it.
Hi, sir.
Hello, I'm just seeing if there's questions or.
So are we allowed to convert it to base 10 and then multiply it and then convert it back? Or do you want us to?
If I were to do this, can I just do a quick one here?
Uh-huh.
Sure.
I'm not sure I can write on this, so that's the only thing.
You can write on it. You can, yeah. Draw on it as well.
I can't find the palette.
If you go up to, I think it's view options and then annotate.
I think I need, oh yeah, okay, good, thanks.
Yeah.
Okay. Okay, so let's say I'll do it in a different color. Oh good, I am in a different color, okay. Okay, so I want to do let's say I want to do 33 times 45, base 60. So now I'm doing this base 60. So what I would do is I would go off to the side and do this base 10. And I'm just doing it because I'd rather multiply by 3 than 5. Oh, I don't like how it does that. Okay. So what do I get? 5. Notice what I'm doing. Get out of there. Sorry. My name tag. I know why it's doing that. Okay, good. Can I take? Yeah. Okay, good. So 3 times 5 is 15. And what do I do with the 1? I carry it over here. And then 3 times 4 is 12. So I add the 1. So I get 135. And then I do the same thing here. I'm going to get the same number, 135. Okay. So 5, 8, 3. Now I want to do this base 60. So let me add another number here just to make it a little bit different. Okay, good. Okay, so I need to convert 385 to base 60 because over here everything's going to be in base 60. This is my scratch work that you'll submit if you have to submit this. So I need to convert this to base 60. So how do I do that? Because here we're in base 10, I want to put it in base 60. Now, am I going to be in the 60s place, or do I need to go up to the 60 squared place here? Like, is my answer going to have three sexagesimal places or 2? And how do I know that?
2, I think.
Yeah, you're right. And how do I know that?
Less than 3,600.
Yeah, I'm less than that. So I divide by 60. I think I get 33.5. Is that right? Sorry, 23. Okay. I'm pretty sure that's right. Okay, good. So let's say it's right. Okay, so I put a 5 here, just like we put, a 5 here, and then I have, how much do I have to carry now? Here I carried 1 because I got 15. 3 times 5 is 15. Here I get 45 times 33 base 60. That's going to be 23.5. So what do I carry over here? Remember, think about this. 3 times 15 was 15. When I did this one, so I put the 5 here, and I put the 1 over here and carried, right?
Uh-huh.
So how about over here? I'm going to put the 5 here, and that's what I'm going to carry. So and remember over here for that 1, what did I do? I multiplied 3 times 4 and added 1. Here I multiply 45 plus 2, which gives me 90. I add 23, that gives me 113. And I'm going to convert that to, that's base 10. And now I need to convert it to base 60. So that's going to be 60 goes in 113 one time with the remainder of 53. So I'm going to have a 53 here. And now I have that 1 to carry. So that's what I would get. Does that make sense?
I'm going to be honest, this is not making sense to me.
Let's go back and do multiplication. You tell me what I do base 10. Walk me through what I do and why I do what I do. So we'll erase all that and do it all again.
Okay. So you multiply it place by place,
Right.
and then once you're done with the first part, you go to the second part, but you move it up up by an order of 10, and then add it together.
Yeah. So I multiply 3 times 5, I get 15. What do I do?
So you bring down the 5 and then carry the 1.
Okay. Now let's go over here. I multiply 45 by 35. I got 23.5. Here, what do I do with the 5?
So you bring down the 5 and then carry the 23.
Exactly.
Okay.
Now what do I do with that 23? Well, let's do this. 3 times 4, but what do I do with that 1?
So you multiply 3 times 4 and then add the 1.
So I get a 3 for this place, right?
Right.
And I have to, what do I have to do with it's 13, but what do I do with that 1? I actually, you never
just-
do it. I carry it.
You carry it, yeah.
Okay. Okay, so I get 45 times 20, and that's going to be 153. Let's just say you magically know that. Tell me what I do. Sorry, I get
So
40,
you-
I get 45 times 2 and I get 90. Sorry, let's do that.
Right.
I got that 23 hanging around, so what do I do with the 23?
You add it to 90.
Yep, just like I added the 1 up here. And then I get what would be called, if you were Babylonian, 1 comma 53.
Uh-huh.
So tell me what to do with the 53 and the 1.
You add it to the 5.
I put the 53 here. That's supposed to be a 53. Sorry, it was really ugly. So that's like putting the number here. Then I have that extra 1, and that goes here. Just like over here, 3 times 12, add 1, I got 13. I put the 1's place here, and then I carry the 10's place over here. Here I put the 1's place here. It's still a 1's place. And then in the 60th place, I have to do that extra 1 over here.
Right.
Right.
Okay. That makes a little more sense.
And you might just have to do it. And
Right.
it's alien because you haven't thought about, I'm guessing, thought about this for years.
Yeah. Well,
You know.
I've never thought about it in base 60. So
Right, but even in base 10, I think the algorithm, you just do it. You don't think about what the algorithm is.
right,
And in
right,
order to do it in base 60, you have to really know the algorithm.
right.
Otherwise, this happened to me, so it's no big deal.
Mm-hmm.
And then, so let's say we had a sexagesimal place here and here. Okay. And let's multiply a decimal, 3.1 times, I'm going to make it easy, 1.2. Sorry, 310, 62. I think it's 272 or 2 point. I think it's, so sorry. Let me erase all that stuff. So what I do is I'm going to, instead of doing that, this is the old fashioned like pre-calculator way. You do 31 times 12. I get 620 times 31, so I get 651. Let's assume that's right.
I think that's right. Yeah.
But now I have 2 decimals, so how do I change that to the right decimal answer?
You just need to move the decimal over 2 places.
1, 2, right here. Okay. Now what do I do here? How many sexagesimal places am I? Yeah.
Is it
Two
still
as well.
2,
Yeah.
right? Or
2. Yeah, exactly. Yeah.
I see.
Yeah.
So then it's 1 semicolon
Right.
3 5.
Yeah, and if you think of multiplying 45, which is almost 3/4 times 2, that makes sense. Like if we multiply 2 semicolon 33, it's a little bit over 2 times 3/4.
hmm
45 is, it's going to be, you know, a little bit bigger than 1/2. I mean, you know, but not quite to 2. So that makes sense in terms of the magnitudes.
Right.
Just like over here, 2 times 3.1, 1 times 3.1. Wait, I didn't do that right. This should be 3 right here. So we, again, now I knew that because I went back and checked, you know, 1 times 3.1 shouldn't be 6, right? So I realized I made a mistake.
Uh-huh.
Yeah. And it just takes a while. So don't sweat it too much. I mean, you'll get a homework problem for it. I'm sure you'll figure it out when the time comes.
Okay.
But
That's the time to figure it out, right? Is at the
Yeah.
last minute when
Right.
the homework is due?
no, but see if you can at least get this started and just like I did here, what I have to do is I have to do I do all the computations in base 10, then I convert them to base 60, and then I put, it's as if I'm sort of simulating doing it by base 60, but I'm really being sneaky about it. And I have to do the base 10 in order to get to the base 60.
Right.
Right. And I have no idea how the Babylonians thought, you know, it's kind of astounds me that they would be able to do in base 60 what we do in base 10 in terms of doing stuff in our heads.
Right. Because, yeah, it seems like it just seems objectively harder to wrap your head around just because the scale is different.
Now keep that thought in mind because we're going to address that thought later today.
Okay.
Okay.
Sir, is the answer that you put on the
Right. It
paper
should be
correct?
711.
Yeah, I was like, am I
Well,
wrong?
I sent an email out after, I realized that after class yesterday. And so I sent an email out but it's fine if you didn't get it.
Oh, I didn't. I think I didn't got the email. That's why.
Yeah. Okay.
Yeah, but I found 7-Eleven like most
Right.
of the time.
Yeah. Okay. Well, I'm going to go to room 3. They have a question and then I'll be back.
All right.
Okay.
Good.
Yep. Bye-bye. Does that help, by the way, before I leave?
Yes,
Yeah, okay.
definitely.
Good. Hey, everybody. You're long done, right?
Yeah.
Yeah, okay. Somebody was having really a hard time figuring out multiplication. So
Hmm.
we spent, which is understandable.
I was just gonna ask if you wanted us to work on the next handout as well.
Yeah, go ahead.
Okay.
Okay. I'd be curious to see if it makes any sense.
Okay. So I'll see if I can do anything with it.
Right. What you have is you have tables of multiplication and also some that are fractional. And so, you know, we were just talking in the other group about I don't know how the Babylonians did it. Like, you know, we can do base 10 and the numbers aren't so big. So it's kind of easy to do it easy-ish to do it in our head if the numbers aren't too big. Like, you know, if you multiply any 2-digit number, any 1-digit number, we know, we memorize that in elementary school. Most of us, you know, but imagine doing that base 60, you'd have to be able to have all the numbers from 59 times 59 in your head. That's a lot different than having all the numbers up to 9 times 9.
That is a lot.
Right. And so I wonder, I'm always thinking to myself, how do they do that? You know, what's their intuition? And we're going to address that. These tables, I think, provide the answer to that question.
Mm-hmm.
So go ahead and look at it. And then I'd be happy if you could figure it out. But I think it might take some explaining. So don't worry if it doesn't make sense.
Okay.
Okay.
Sounds good.
Yep. Okay. I should be back in a couple minutes.
Sounds good. Thank you.
Yep. Bye-bye. So I'm just walking through rooms. Are you well on your way to get, oh, you're back in the main session, right? Yeah.
My Wi-Fi cut out, so then I got kicked out, but then I came back here.
Oh, I didn't even notice. Okay. You got back. Yeah.
I've
Yeah.
been chilling.
Is this making stuff? It's making sense?
Yeah, I just went through the number 7 and I got it correct.
Good. So we're going to start number 6 in a bit. You can start that, but it's not going to make much sense, I don't think.
Like worksheet 6?
Yeah.
Oh, okay.
Okay. It's in the week 4 folder there.
Are they staying in the breakout rooms or?
Yeah, I'm going to go get
Come
him and
back.
bring him back. You want
Okay,
me to?
sounds
You want to go back and you lonely? You want me to put you
No,
back
no.
in there? Okay.
I'll just chill here.
Okay. Good. Okay. Are you ready to join?
Yeah, it seems like we're converging on an answer.
Okay. Yeah, it'll be a minute. I'll give you another minute or two to let that come.
Yeah, we're almost there.
say, I'll let the convergence take place. Okay, so I'm going to go and visit and bring everybody back in a couple of minutes, but I'll give you the time.
Sounds good.
Okay.
Hey, Eric got kicked out, and then he's back in the main room. Are you all are you good, or do you need more time? Got it? Okay, good. Okay, good. I'll close the room. You can go and talk to Eric. He's just sitting out there by himself. He was able to get back in. I didn't know he had gotten kicked out. Oh, can I? No, I can't do that. Let's see. I'm trying just to end your room and I can't, so I can't do that. So I'll leave you there just for another minute. It won't be long.
I was like, there are no numbers anywhere.
Yeah.
How's it going?
Not too bad. I'm just drawing it out.
Right.
Try my best to do it by hand.
So a couple more minutes?
Yeah, sure.
Sure. Okay. Or do you need that? Are you good?
I think either way is fine.
Okay, good.
Yeah, I'm just drawing it out.
Yeah, okay. One group is finishing, so I said I'd leave a couple more minutes, so I'll just do that.
Oh, I do want to ask, like, so I found the answer, but I think I put the comma wrong. So
Yeah.
I don't know how to put the comma back into it. That's the
Okay.
problem with me right now.
Okay. Remember the example we did? How many places are you taking if you don't have if you don't have the semicolon?
Oh no, I know when to put the semicolon, but I don't know where to put the comma now. So because I found like 40, but I put a comma here. So
You're adding, right?
Put the commas in between all the numbers.
Thanks, Hannah.
does that mean that that's a comma here as well? Or just
I think you cut out for a second.
finish drawing this out, and I'll show you what it means.
You're suddenly really
Your
quiet.
headset, yeah.
Yep. Got it. No.
The 40 is just one number.
Hannah's right. That's 8 times 20, which is 160, which is 240. Yeah. So when you write it out, Kika, just make sure you keep keep each place close together. Now, if it gets too spread out, I think you can confuse yourself. Okay. I'll see you back in the main room. Oh. I left myself in the breakout room and I closed them. I couldn't figure out what was going on. But, okay. I think everybody's back, looks like. Yeah. We might have lost somebody. Oh, I think that, is Colin still here?
Yes, I am still here.
Oh, you are still here. I know you were having trouble earlier, but, oh no, everybody came back. Yeah, we got 16. We got the right number. Okay, good. Okay, so I'm gonna, any questions? Did it work out okay?
Any question?
Sure, Paige, yeah.
So we figured out, we got to the part where it was like 7, 11, 24.
Mm-hmm.
But I'm confused on why, since 24 is the remainder after you do the division.
Right.
Why is it on the right side of the semicolon instead of the left?
Okay. Let me try to answer that by doing something in base 10. Okay, so I'm just going to do just like multiplication, 2.3 times 4.5. I don't like decimals. They confuse me. So I'm going to do 45 times 23.
Okay.
Get my answer, 5 times 3, 1, carry 1. That's 11. And then I carry the other one, 1, which you're all experts in this now. 4 times 3 is 12. Carry 1, 4 times 2 is 8, 9. So I get 5, 3, 0, carry the 1. So where do I put that decimal?
After the 0.
Right, you move it twice. So you have a number like this when you're done. I just want to make sure I write it down correctly. So 7, and sorry for that mistake, having this 11 and not on the original one, and not, so for having 13 and not 11, sorry. Okay. Comma, 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 sorry, okay. Now, when I do this, let's say I took away all the places, and how many places did I take away? I took away all the semicolons, right? So how many places did that affect?
Was it 3?
3, because it was, 23, 0, semicolon 20, and then 18, semicolon 45, 8. And so I got 1, 2, 3, just like here I had 2. So now I have to compensate 1, 2, 3.
Oh, okay, okay.
Okay. And if if you ever get like, if you're not sure and you need a check, you can do like an order of magnitude check. Somebody did this earlier and it's 414. Sorry, this isn't going to work. Yeah, no, it's not working very well to me. Forget it. Forget what I was doing. It's not worth it. But did that answer your question, Paige?
Yeah.
Good. Okay. Okay. Are there other questions? And the thing here that's so insane about this is like, it's like really what it comes down to, the difficulties. It's a new situation. It's this multiplication of like I was telling somebody before, we need to multiply 9 times 9 to pretty much do base 10 pretty quickly. That's the key to learning, your times tables, because then you can do bigger place by place. But they had to do 59 times 59, which is a much, much harder task. And so what we're gonna like talk about next, and I wish I had a demo of this, but I can see it in my head. So imagine this story, like here's what the Babylonians did. Like we used to have these books of log tables and sine tables and all kinds of, and so if you had to do a big computation, you might, bring out your log table and you'd look up the logarithms and so, but we had these tables and they were books. You can't see my hands. And so we just open the books and find it on a table. And the tables, the books had like, I have them in my office, but that doesn't do us any good. But, 50, 60, 80 pages, and these sine tables and logarithmic things like that. So what they had are tablets, and they had a lot of multiplication tables. And they don't just need 9 times 9, they need everything, and they need A times B up to 59 times 59. And so they had these on those tablets. And let's say the tablets are as big as a piece of paper. And then let's say that I have that collection of tablets, and these are multiplication tablets. So maybe for for 1 times, the 1 times, the 2 times, 3 times, and so here are my tablets, and I want to multiply 33 times 52. I just kind of look through my tablets. I'm getting, these are bigger, these are clay, so they're probably in a drawer. And I'm pulling the drawer out and I'm shuffling through and I'm looking, oh good, I want to multiply 23 times 33. Here's my 23 table. And then I can figure it out. So that's probably, we have good evidence that that's what they did. And if you think psychologically, 59 times 59 to have in your head, I'm not saying they didn't do it, the good ones, but it would be hard. Okay, so does that make sense in terms of like how you might do it? You would use tables. Like we were going things off to the side, had to convert to base 10, then back to base 60. They would just be looking up a table. Let's just imagine that's true. Okay, now this is a snippet of a table, and it's a multiples of 1 times 30, which is 90. I mean 1 comma 30, which is 90. And so notice that if I do 1 times 130, I get 130. If I do 2 times 130, that's going to be 130 plus 130, which is 260, which is 3. So I get 3, 180, yep. 3 times 130 is going to be 430. Now here we get up to, this keeps going. Now I want to do 13 times 130. And I look it up. 13 times 130 is 19 comma 30. I have it all in the table. 180, you can check it. 13 times 90 is going to be 180. And then they have like, so here they have 1 through 9. Here they have 10 through 19. And then we have 20, 30, 40, 50. Notice we don't have 20 plus 33, plus we don't have 1 for 23 or 35, right? It's just the whole digits. Okay, so let's say that I want to, so that's what this, don't even worry about that second table yet. So I want to use that table to multiply something. Now, you have an answer, you have a problem, but I'm going to multiply a different one. 122 times 131. Okay. Now I'm going to think of this as 1, 0 plus just one place, 22. And I'm going to think of this as 130 plus 1. So I have 122 times 131. And now I'm going to use this. That's going to be equal to, oops. That's 22, sorry. So I have two, what do you call those, binomials? So I'm going to FOIL. This is equal to this, using, right, by just distributing. And then now I want to multiply all this out, so I do this. I do 10 times 130 plus 1 comma 0 times 1. Then I do the, let's say I did 10, I do 22 times that. Plus 22 times 1. So I haven't done anything else yet, but do you follow me on this? Here, if you have a question, you can chat it out or shout it out, but I just don't want to keep going if people aren't following. And this seems convoluted, but so don't even think about that part yet. But mathematically, do you agree that multiplying this is the same as multiplying this, and that's equal to this?
Yeah, that makes sense.
Okay. Now notice I can use the table for this. I know 1 times 30 is 1 comma 30, right? Sorry. So, but I have an extra decimal place. So what is, it's not 1 times 30, it's 1 comma 0 times 1 comma 30. So how do I write my answer? I see that 1 times is 1 comma 30. So what would be 1, 0? Remember, this is going to be 1 times 30. Here. This is equal to 1 times 60. Do you agree with that? Okay. So what I'm doing here really is I'm doing this. I'm pretending this is 1 times 130. But then I have to multiply by 60, right? Because I divided that by 60. So it's like using scientific notation. So 1 times 130, I look on the table and I get 1 comma 30. What would 1, 0 be? What I have to add an extra place, right? So I would get this is now 130, 0. Because it's the entry in the table times 60. To do times 60, you just move the decimal place over or the comma over. Okay. Now I do this over here, 1 comma 0 times 1 is 1 comma 0. 22. I look in the table. Dang, I don't have a 22 there. So now I have to do this further and think of this 20 plus 2 times 1 comma 30. I can use my table. I go 2 times 1 comma 30, that's 3 comma 0. And then I do 20 times 1 comma 30. That's going to be 30 comma 0. So now I can use the table for these things. And then I have this last one over here, and that's just plus 22. So now I can add things together. But before I do that, sorry, I know I'm off the screen. Does that make mathematical sense that this now becomes this? And if you think about the scribe, they're looking up the tables. And so they have to break it down because they're going to use different tables for different multiplications. I concocted this so we could just use this one table. And so if you imagine if you did this day after day after day after day, if you were an accountant, you got pretty good at this, or if you're an actuary, I think maybe that's too early for insurance. I can't remember, but there might have been some small things about insurance back then. I can't remember. Might have been some shared risk concepts, so they got really adept at this. So anyway, but you have to break it down. And so we have these 5 numbers we have to add. So 130, 0, 1, 0, 3, 0. I'm not leaving myself much space. 30, 0, and 22. So I do the ones column and I get 22. 33, I get 64. And what do I do with that 64? Put the 4 here and carry a 1. So that's what I get for my answer. Okay. And so if you were to do this like a Babylonian and not do those little things off to the side like we did before, you would be using tables like like this one. And you'd be really good at it, and you'd probably start to memorize these just if you're doing this day after day. So you'd figure out shortcuts and it wouldn't be as convoluted as what we're doing. It would be a lot smoother. But think about what we had to do to use the table. We had to break this down into combinations of numbers. And now because they're either easy multiplications or they're by 130, and we have the table for the 130. And then we go through, we run here, we can't do 22 times, it's not on the table. And this is how we think it was. They didn't have entries for 21, but they used stuff over here like we did, 20 plus 2. So I can use the 20 plus 2 entries on the 130 table. And so if we were to do like 522 times 385, we'd go to the right table and figure that out. Okay. So that's one part of the table. And so just try to do, did we have one? I don't know why I say multiply. Oh, again, using the table, I know what I mean there. So I'm going to break you into groups again, and then just do the multiplication, and maybe we'll come back and be able to talk about the table. But I'm going to ask you, when you multiply by fractions, do you ever convert it to a decimal and then multiply the decimal times the whole number? Like with calculators, you do. The second table, it's kind of the same thing. It's a way of turning reciprocals. Remember, division by 15 is multiplying times 1 over 15. It's to determine, this is a way to use multiplication of reciprocals to divide. That's what that second table is, but we'll get to that. But if you get finished quickly and want to start trying to figure it out, go ahead and do that. And it's a partial table. So anyway, I'm going to break you into groups and just work on 1 and 2. And then again, I'll come around and see how you're doing. Okay. No, that didn't do what it was supposed to do. So I'm going to not do it that way. Sorry, Zoom frustrates me sometimes. It says recreate the rooms, which would be recreate the rooms we used a minute ago. No, completely different rooms. Okay. Anyway, I'm going to send you all off to work together. Eric, it didn't put you anywhere. I'm going to put you in room 2.
Supposed to be looking at handout number 6 or the same one?
Well, the one that I was just showing you, number 6.
The 6, okay.
Yeah, and the first 2 questions.
Okay.
And
That makes a lot more sense.
so what do you think that the first step is going to be when you multiply those 2 numbers? Remember on the answer I did, I took apart the numbers so I could exploit the 130. So you might want to think about, like, I'm going to share the screen just to get you started. You've got to multiply by 132. So think of that as that. Remember before, what we did is essentially FOIL. And so now you have to multiply by 154. And so you'll want to think how to handle that. And remember, you're going to be multiplying times 130. So again, you have a 1 here, you have 154. And to me, it makes sense to multiply by 1 because that's easy. Then you can use the 50 entry on the table. You have 50 times 130. You don't have 54, unfortunately, but you do have 4 times 130. So if you break it up that way, now you can just FOIL and distribute and use the table entries. So you can do 1 times 130, yep. 5 times 50 times 130, yep, you can use the table there. And then you can do 4 times 130.
And the 130 is supposed to be 1 over 30 or?
1 comma 30. Remember you have that table, multiples of 130? At the
Okay.
top. That's your encryption key right there, or decryption,
Okay.
however you want to think about it.
So it would be like 90.
Yeah, but try not to do it in base 10. Try to do it in base 60 using the table.
Okay.
Because to multiply 50 times 130, you go to see where the table says 50?
Mm-hmm.
That number you have next to it is 50 times 130. Or 50 times 90, if you want to think base 10. So that number 1 comma 15 comma 0 is what you get when you multiply 50 times 130.
Okay.
40, the number next to that, that's when you get 40 times 130. You get 1 comma 0 0. So what that table is, somebody's already worked out all the details, so you just have to sort of figure out how to apply it to the number that you're using. Okay. It's an alien way of thinking, so it takes a while to get used to it. And really, we're using the distributive rule, like you learned that way back when. That's what we're using here. And then just to complete this picture, we do the same thing. Then we multiply 1 times 2, 50 times 2, and then 4 times 2. And the first one, you multiplied it all times this number. And those should just be numbers that you can kind of do in your head because they're small numbers. Or off to the side. Okay. Is that helpful?
Yeah.
Okay. Sorry, I lost. Oh, yeah. Okay. I'm going to stop straight. What? You want me to leave that up or? Oh, I think I stopped
No,
sharing.
I got it.
Okay. Okay. Any questions before I go?
I don't think so.
Okay, good. Is this a good quiet? I mean, is it making sense?
I think so. I got booted again when you were explaining everything, but I'm figuring it out.
Good. I'm glad you're able to get back in. Are you on campus?
Just off campus.
Okay, yeah. 'Cause I know some people that this has been happening in my other class today. Some certain people kept getting booted out.
Just today, though?
Yeah.
Yeah, because we haven't had this ever before, but kind of weird.
Yeah. Okay. Anybody else have a question? Okay. I'm happy to hear that. Okay. Just checking in to see if there's any questions. Everybody's quiet. I'm taking that as a good sign. Good.
I guess, yeah.
Oh, Kika, I can barely hear you. I don't know if you can turn up your volume.
Can you hear me now?
A little bit, only a little bit better.
I think my mic.
Yeah.
Working.
This happened before.
Oh, really?
In the last room, I mean.
Oh, that's weird. Yeah, but
I can hear you, but it's just low, that's all.
I just can't adjust it. All right. So the first one is just splitting them up and use the table to like calculate it, right?
Yeah, you have to break it up like we did before, and I had to break it up into one of them into 3 pieces. Like
So it's like, yeah, 130 plus 2 times 130 plus 20 plus 4.
I did 50 plus 4.
I tried to do that as well, but there's no 50.
Yes, there. If you look on the table on the right side.
Oh, the last one. Okay.
Yeah. Yeah.
Oh, okay.
Yeah.
All right. Let's see.
Okay, I'm gonna go check out another room. Seems like you're doing good.
All right.
Okay, I still got 2,55,8. I'm gonna go up over it.
Hello.
Hi.
You working it out pretty well?
We have differing answers for number 1.
Oh, okay. I don't know. Let me see if I have it. I think I worked it out, but I have to find it. And remember, my answer doesn't mean it's the right one. Let's make sure I did the right numbers. 130. Oh, no, I was doing some of the harder ones. These aren't this. I didn't do this one. But no, I didn't. So what are the 2 answers, or where do they differ?
So I have 2,54,48.
And I got 2,55,8.
Oh, okay. Let's see. You want the slow way, or do you just want me to check it?
Just check it for now.
Yeah, okay. And you did 130 plus 2 plus 1 plus 50 plus 4?
What, how can you repeat that?
Can you repeat that?
Yeah, I broke it up as 1 comma 30 plus 2 for one term times 10 plus 50 plus 4 for the other term.
I broke it down like I did 1,30 times 1, 1,30 times 50, 1,30 times 4, 2
Right.
times 1,0, 2 times 50, and 2 times 4.
That's exactly what yeah. I was doing the
Okay.
same thing, but just saying it a different way.
Yeah, Bryce, I think you have the right answer. I just converted from the 92 times 114, and it's your answer.
Okay. Well, it's my second answer. My first answer wasn't correct.
So what did you decide was correct?
2,54, 48.
It's a miracle.
Yes.
I got that too. Okay, good. So, okay.
So we did that.
Okay, so
And
it
then
seems like
I've also got the answers for 2, 3, and 4. And I tried to look at 5. I don't know how to do 5.
Okay.
I know how to do, I could do it. I don't know how to do it with the tables though. I could do it with like long division.
Right.
And just do it in sexagesimal.
Right. What I would do is I'd find the reciprocal of 50, which is in that table.
Which is 1,12.
Right. And then multiply that times 133.
What?
Yeah, here, look here. Let me show you what I mean. Oh, let's see. I can write it on here.
Oh, you can annotate it. Yeah.
Yeah, and I forgot that I can do that. But so like, if we do this, is do this, and that's what's that? 83 divided by 50. Oops, that's all right. $83 times 50. 83 divided by 50.
Uh-huh.
Is equal to 83 times 1 over 50.
Yes.
And 1 over 50 is what, 0.02? This is all base 10.
Oh, and then we have to divide by 60 at the end, don't we?
Then you got to, then you got to figure out what you need to divide by.
Because the reciprocal for these are to get
right.
1,0.
Right. In order to be flexible, you have to put in, that's where the skill comes in. You have to know where to put the decimal place.
Okay. Cool.
So
I got it now.
Yeah.
Thank you.
Okay, good. Okay, good. So I think I'm going to go see how other people are doing. You're way ahead, your group, so.
Okay.
Okay.
For the second one?
Well, that
Yeah.
should work, shouldn't it? Or yeah, it'd be 1 comma 30 plus, and then you could do like plus 50 plus 4, maybe.
For number 2?
Yeah.
Yeah.
You mean 20 plus 4, right?
That's
Is it supposed to be like 2
That's what I
plus
had.
20 plus 4?
Well, I'm seeing 131 by 224.
Yeah. So the equation for 224,
Uh-huh.
would it make sense to be, because in the table it says it's like 3 comma 0.
Right, for 20, yep.
Yeah. Or wait. For
I mean, I guess you could use your old, never mind. I think I'm just making it worse.
I had 3 comma 0 plus 20 plus 4.
Here's how I would set it up. Okay. Sorry, it's too many. Sorry, I just forgot where I was. And which screen? Okay, so I would do 130 plus 1. Is that right? It's 131. Yeah. And this is tricky. I mean, it's like, it does take getting used to. 2, comma 0. And then plus 24. So I would do plus 20 plus 4.
How come you did 2 comma 0?
Because it's 2. Oh, well, because you know why? Because I'm going to do, I don't care about these. I'm going to add them at the end. So I'm pretending those numbers aren't there, the semicolons, because they just confuse me. So what do I have to do at the end? Where do I put it? How many places do I have to go in?
2.
Yeah.
Okay.
Okay. I just find that way easier. I mean, I guess I could put it here and then just work on the table, but I'd rather use the table and then figure out what to do next. You know, wait to the end for the semicolons. But that could be me. Okay, does that help?
Yeah, kind of. Well, okay, so for the 2 on the table.
Yeah, what do you have to add to the table to get, because we're doing 20, we're doing 2 comma 0, which is 2 times 60. The table gives us this. So what do you have to, how do you find out what happens when you have the extra place here? Like that's 2 times 130, but we're doing 2 times 130 times 60.
Okay.
So I add another one here.
Okay.
Right. Because here multiplying by 60 is the same that we have as adding a 0, just the way that multiplying by 10 adds a 0 in base 10. So I'm thinking of like 2 0 as, and I'm cheating to write 60, but 60 times 2. And notice the math works out. It is 120, that's 120. And so then when I multiply that times 130, I use the table here and I get 3 comma 0. But now I have to multiply by that 60. And what that's going to do is it's just going to add another decimal place. I mean, another sexagesimal place. Just like 10 times 30 would be 300. 60 times 3 comma 0 is 3 comma 0 comma 0. 3 comma 0 comma 0. And you know what you want to think of is like that 10 times 30 in base 10. You take the 30 and add a 0. And that's exactly what we did here. Okay. Hopefully that's helpful. This stuff is confusing for sure. We're getting near the end of class, so I was going to bring everybody back in a minute or so, but I'll give you some time to collect your thoughts. And just getting through 1 and 2 is fine. So no worries. You want me to stop the share, or do you want to keep it up?
I've got it written down.
Okay, good. Okay. Okay, so I'm going to bring everybody back in about a minute.
Okay.
Still quiet? Still a good thing? Did you get past number 2?
I'm still working at it.
That's fine. I didn't expect people to, but yeah. But do you think you got it down? It's just a question of cranking it out?
No, I missed the explanation. So
okay,
I've been trying to figure it out on my own.
Okay. So anybody here have a question? Okay. And if you want to stick around, Eric, I'm going to bring everybody back because it's almost time to end the class. I can go over, if you missed something, I'm happy to go over it after class. Okay. You know, I'm going to bring everybody back just because we're getting near the end. Waiting for some more people to come back. Good. Good. Okay, I think everybody's back. Okay, so there's about 2 minutes left. If people have questions, I'll be happy to sorry, I'm just looking at what he did. Okay, good. Number one. I'll be happy to stick around and answer questions. But what did people get for the answer for number 2?
Um, 3:38, 24.
Do people agree with that? Disagree?
I got the same thing.
Does it seem reasonable looking at the 2 numbers you're multiplying?
Yeah.
Yeah.
Because one of them's basically 1.5, and one of them's a bit more than 2, so it makes sense to get a bit more than 3.
Yeah. Okay. So in the way I did it, I forget about the semicolons. I broke it up that way. Sorry, I'm not very centered on here. And then got 3:38, 24, and then I just moved the decimal place over twice because I moved it over twice to multiply. And then this is how I had to break it up to use the tables. And so it's convoluted, but I hope you're getting a sense that, like, if you did this every day for 6 hours a day, you know, because you're good at math and they stuck you in like working, you know, doing computations all day, that you would get really good at this, you know, because you'd be doing it over and over again. But just imagine that you'd be like, you know, you'd probably find a couple of tables that you could rely on. Like we could even do, you know, if I wanted to do 141. Now I don't have a table, but I could do 130 plus 10 plus 1. And those are nice, easy numbers to multiply by. So this table is actually probably could be used for more. You maybe be nice to have a table for the 140s, but you might get sick of looking at all those tables and just pick out a few of your favorites and have them that you rely on. So anyway, so I think what I think is really interesting about this for me is, and then I'll shut up and go, but it is that it's so hard to do 59 times 59, but they adapted by having this elaborate system of tables. And it's really not unlike the way that people did math before computers. If you think about it, a lot of the methods are the same, just different numbers. How many physics majors here? Ex or former, present? I'm sure there's.
I'm a former physics major.
I thought so. I thought so. So anyway, if you look at like ancient, like not even ancient, but if you look at astronomical tables from, like, let's say you were alive in the 14 or 1500s AD in the Common Era, you would have seen sexagesimal observational tables because so many observations were made with base 60 that they just, you know, it was just too hard to change all the tables. So this actually persisted for quite a while, this base 60. Okay, that's all I'll say. So anyway, so I'll let you all go, but if you have any questions, I'll be happy to stick around. we'll finish up these guys on Tuesday. I don't think I think I'm gonna save the introduction to the Greeks before Thursday. Thursday, we'll talk about the Greeks a little bit, then I'll frame the questions that you're getting. I'll probably do a couple of things and then give you some time to start thinking about how you're gonna do the next project. I mean, the next presentation. And then we'll have a problem set coming up soon too. It's about time for one. Okay. But anyway, I'll stick around if you have questions. Otherwise, have a good weekend and I'll see you next week. I'm sorry to keep you a little bit late.
Have a good weekend, Professor.
Have a good weekend.
You too.
Thanks, Dr. Alexander.
Good weekend.
Okay, you too. Thank you.
Bye-bye, sir.
Bye-bye, Kika.
So I got the first one,
Okay.
number 1. I think I'm just checking my.
Did you see how I set it up? Did that make sense?
No, I missed that part.
Okay.
But I think I'm guessing I know how you did it. You split it into like a 130, and then you multiply that by the other number.
Right.
So for the first one, you have 130 times 154, and do each part of that, and then the 2.
Yeah.
You can do at the end.
Yeah, I did it. I did 130
Pretty much
plus
it.
1, and then 2, 0, 20 plus 4, just so I could use the tables. But there's different ways to do it. Yeah.
That's as far as we need to go
Well, multiply it out.
on
Yeah.
the worksheet. Yeah.
Oh yeah, yeah,
That's
yeah.
like number 1 and 2 on the worksheet.
Yeah, exactly. 1 and 2. We didn't really get to these, so no worries about that.
Okay.
Okay.
Sounds good. Thank you.
Okay. I'll take care, Eric. Have a good weekend.
I'll see you later. Thanks.
Yeah, bye-bye.